All right, folks. Today we're going to be chatting about gas metal arc welding welders. MIG welders, you know, they've got lots of different names. Wire welders, but this is a gas metal arc welder. GMAW is the process name. MIG is a term that's used, stands for metal inert gas, but some gases aren't inert, so it's not really a great term for it. Gas metal arc welding is a more proper term for this. This machine is pretty simple, and that's why I chose this one to talk to you guys about today. This one's also a miller, and I have another miller that's a little more complicated we're going to talk about later, so you can kind of make a direct comparison between two products from the same company. This one here is a Millermatic 212. It's a fairly small version of a shop welder, but it will work for what we're doing. It's perfect for in here. We're not using it a whole bunch day in, day out, burning heavy wire at high amperage. So something like this is just fine for in here. If I was doing a little bit more welding, I'd get something like a 252, which is a bigger welder. It could take a little more. I used to run one of those at my old job, Lafarge. So I've got a lot of confidence in the Miller products in a shop setting. So I want to go over the basics of this. I've got the cables wrapped up on the front of it here, and we're going to pop these off. And we're going to talk about the cables, the settings, all of that fun stuff. Some people may argue with me, but this is the most important part of the whole process. A lot of people don't even think about it. This is a ground clamp. And this ground clamp is what completes our welding connection. So on the table there, we clamp this here, right on the table, and then we weld with our welder. Without this being connected properly, there is no welding happening. So this is a very important part of the process. It's a spring clamp. To squeeze it, stick it on the table. We just got to make sure that it's in good condition, that the little jaws on the front there are in good condition, and that this cable here is attached securely. So we don't want to have any loose components in here. That's going to add resistance to our weld. It's going to take away power from our welder, and resistance is heat. You can burn up the cables, and that is not a good thing. That's not something we want to do. So these have to be connected to the table before any work can happen. Now you can connect it to the underside of the table. You can connect it to a bolt on the floor on the bottom of the table. It just has to be in that circuit. So that is a ground clamp. It's fixed to the machine permanently. It attaches right here. There's no way to remove this unless you open up the cover, unbolt the lug, and take this out. So damaging one of these cables is kind of a pain in the butt, but not near as big of a deal as if we damage a Stinger or a MIG gun. So yeah, if these do get damaged, we can fix them. Not a big deal. Fix them, replace them. It happens. I've cut lots of cables in my time, cut them clean in half. I've had cables fall into machinery, and yeah, it hasn't been good. So I've definitely had to fix a few cables in my time. But that is that for the ground clamp. So it needs to be connected. This makes everything happen. So the next thing here we have is, push this back a little bit so you guys can see it, the MIG gun itself. Now, this one is fairly long, 10 feet-ish, maybe a little longer. A nice heavy-duty Bernard gun. So this one has been switched from the original Miller gun. The original Miller one for the 212 is a lot lighter duty, and it's a little easier to manipulate, but it can't take the abuse and the heat that a bigger Bernard gun like this can. And nice thing about this gun is it is a standard in welding shops, in industry, everywhere. All the parts for these are readily available. So if we ever have an issue where something gets damaged, I can call up OxyPro, Praxair, whoever I want, and say, hey, I need some cups for your Bernard guns. And they'll know exactly what I'm talking about. And if they don't, nice thing about these guns and these parts are, they put You can't see it. Maybe. Serial numbers on everything. So you can just rattle that off to the guy and he'll go, okay, sounds good. I've got 25 in stock. How many you want? You say 75 and that's great. Same thing with the tips. These tips here, very common. I buy them by like the 50 pack because we go through a fair few here. So they're nice, very readily available. And that is definitely a benefit of having a gun that is more common instead of a lighter duty gun that would have come on this machine. So these Bernards are a nice universal fit for a lot of the millers. They're designed to fit the millers. And they got a few extra features that I really like. So we have a good hefty handle. So you got something nice and big to hold on to, which is great. You want that. Trigger here, nice and available. It's yellow, it's a big one. So if you got those big gloves on, kind of hard to pull, you've got a lot of space here to activate that trigger. Some guns run smaller trigger holes or trigger areas. And if you have big, say winter gloves on, you're working somewhere cold, these are hard to manipulate. But these ones are just great. I like them. We got a nice curved neck here. That curved neck, I don't know if you guys can recall, but this is so when the wire comes up through here, it's forced around the outside of the curve. Kind of like when cars come around a racetrack and they've high banked because of the gravity and then they're up on the high wall. Or if you watch any drifting, I know we got one guy who likes drifting in here. But yeah, this forces contact on the outside of this, which promotes contact with the contact tip, helping you get a good weld every time. Formula Drift, you see LZ got Rookie of the Year. That was pretty awesome. He had that one locked up a long time ago though. He got that 4th place finish a while ago. I think he was up against Forsberg. He lost in a battle like one more time with Forsberg. So that was pretty interesting. I follow a bit of drift too, so it's kind of fun. Yeah, but these are awesome. All these parts are consumable, replaceable. What I really like about these is we have this little coil on the back. And what this does is this stops us from kinking. If this kinks, it's going to create a lot of resistance on the wire. The wire won't be able to flow through here like we want it to. It's going to stub, and stubbing is where basically the wire isn't coming out as fast as it's being burned off, and you're burning the wire back to the tip all the time, which isn't good because you belt it to the tip. That tip's junk. You can't weld anymore. It's a bunch of trash. So this protects that from happening. And in fact, I've got a welder just down the way that this is happening to quite a bit. So if you can see, when I bend it like that, it's got a bend here, and I'm not supporting anything. I'm just holding the gun by the neck. So this stops that from being bent. I'm going to take you guys to another welder right quick here. And I got a little Hobart Beta MIG, just a little guy here in the shop. But see that? This here is a big old kink. And what that does is that stops that wire from coming out the end of the gun like I want it to. This is a pain in the butt, and I got to find a way to fix this. The problem with that welder is it's 25 years old, and I'm having a hard time finding parts for it. So I'm just going to see here. Oh, I don't see anybody in a waiting room, which is good. Yeah, no, that's cool that you've ridden dirt bikes. I love things like that get you out, but you get to learn about it too. It's really good to do stuff like that, because you get to learn how to fix it when you break it, and it's not just ride and have someone else fix it. Okay, so we talked about the gun a bit, but what we're going to do is one other thing on this gun here. So we pop the contact tip off, pop the cup off. Take a look at this right here. So hard to see, but see those holes right there? Yeah, awesome. See ya, Riley. Those holes are where the gas comes out. So the gas comes out of there, but that's inside of here. And that's what directs it down to the cup over your weld. So that's pretty neat. That's how we get good gas coverage on our welds. All right, these guns are removable. They do have a remote contact wire right here that we have to unhook. And then we open up the inside, we disconnect the gun. We have to cut the wire to do that. I'm not gonna do that for you guys today. What I am gonna do though, is I'm going to unplug the welder. I'm gonna turn it sideways and I'm gonna show you what's inside of these things. So here we have the side panel of this welder. Nice thing is this is a big access panel right here. So this will lift up and we got all the guts on the inside. Inside here, what is that? Sorry, just a little something. Inside here, we got our roll of wire, 44 pounds, it's a big one. That's what I like about this is you have to change the wire once, like twice a year. Depends on how much you use them, but 44 pounds is quite a bit of wire. So when I was talking about the ground clamp, I said it runs up here. You guys can't see it. I'm gonna tip it down just a little bit more. All right. So the ground clamp runs on this cable here, which runs just inside of here, and there is the connecting lug for it. So if we want to take this off, we could just unbolt that lug there and be done with it. It would come off no problem. But we got to make sure the power is off when we do that, because right here beside it, it's hard to see, it's red, but it's the exposed hot terminal. So if you're working along with a wrench and all of a sudden you bridge the terminals, what do you think is going to happen? So you're going to arc out, there's going to be sparks, and if it sticks there, you're going to heat up that wrench and you are going to melt it basically. Depends on how much power we're pushing through it and if we blow a fuse or not. But just like on a battery on a vehicle, you don't want to cross terminals, right? It's not going to be good at all. So we've got the hot terminal here, which supplies power to the body of this, and then it comes out through the contact tip. Right here is a little hand wheel, and we would loosen this one to take out the whole welding gun. Right in here, we got roller set up. I got my rollers right in there. I have a tensioner right here. Pretty simple setup. If we have to change polarity or drive rolls and stuff like that, we've got a nice handy dandy guide right here. It's awesome. Super nice for that. So that's always a good bonus to have. Also in here, we've got a hookup for a spool gun. If we're running spool guns, we can, if we want to. It's not a big deal. It's something we have to hook up. The spool gun would be for aluminum. And I showed you guys that in the slideshow. We had the push guns, the pull guns, the push-pull. The aluminum guns are pretty small, and they carry a 2-pound roll of wire in them. Nice thing about that is you can get that gun into all different spots. I don't have one ready to show you guys right now, but so this can do more than just steel. We can weld aluminum with it as well. Not as nice as TIG, but we can definitely get some stuff welded together with an aluminum spool gun. So that's pretty cool. That's the inside. To change these rolls, this collar just pops off. This roll here will just pop off. Not a big deal. It's connected in through the drive rolls, so I obviously can't take it all the way out, but we're just gonna put that back into place. It's nice and simple. You always wanna make sure you feed it the way this is angled. So this setup here is angled low at the bottom and higher at the top. And when you set your wire up, you wanna roll over the top to come down into there. You don't wanna come from the bottom up and then have to crank it down into there. It's gonna put bends in the wire. It's gonna put a lot of resistance on the motor for feeding, and it may work, but the results aren't gonna be near as good as if you have this over the top feeding in, so I can pull it off that roll nice and neat. It's pretty simple setup, and we even have holders in here for another set of drive rolls. So if we were running 045 or had a set of 045 drive rolls, we could put them here. And that way when we change our wire to an 045 roll of wire, we can totally just grab those rolls, pop them into place. And these pop out easy, these drive rollers. I think I've shown you guys before. I'm just gonna take one out here. Let's take the top one out and it should come out just like that. So this one, I'll show you guys, is set up for 2 different sizes. So we got 030 right there. Also gives you a part number, which is super nice if you have to order some new ones, or the metric 0.8 millimeters. We flip it over. What we got here is 035, which is the size we're using, 0.9 millimeters. And we don't need a part number because it's on the other side. So yeah, super cool. They make these things a lot more user-friendly than they used to be. So it's great. So we're going to close the hood on that. And we're going to talk about what's on the back here. It's that big old gas bottle. All right, so this is probably the second most important part of the welder. You know, we talked about the ground clamp being very important and the gas bottle being very important. Gas bottle is important because we need that to shield our weld. Oxygen or air in our atmosphere is only about 18 to 20% oxygen, somewhere in that vicinity. Someone would have to quote me on that, but it's 18 to 20%. We got a lot of other things in our atmosphere, CO2, nitrogen, stuff like that. But long story short, atmosphere, what we breathe, what's around us, terrible for welds, for MIG welds. So what we need to do is we need to cover that weld, that shielding. So this is where we get that shielding, and this is going to be a C25 mix. So that's a 75-25 argon CO2 mix. 75% argon, 25% CO2. CO2 increases penetration depth, but it gives you a rough appearance. Argon gives you decent penetration depth, but a nice appearance. So we combine those two to kind of get the best of both worlds. Kind of like the old automatic transmissions and the old standard transmissions. You know, we've created a dual clutch now, which is a mashup of both, which is kind of the best of both. You still get that gear shift, you control it, but you get the speed of an automatic, but you get the control of a manual transmission. So that's another reference to them car guys out there. I see you, Sauger. Yeah. So that's kind of a neat car reference for that. But yeah, this here is our go juice for a welder. Covers our weld up, allows it to form. So that gas does a few things. Pushes the atmosphere away, oxygen, nitrogen, CO2, all that stuff, gets it out of there. Then puts its own mix over top. So that recipe we got covers that up. So that allows our weld to form without getting porosity. It allows it to harden and cool before being exposed to the atmosphere. So that's really nice. Because even if we cover our weld and then we blow away that gas real quick, there's still, you know, that atmosphere coming in can still have some effects. It might not show porosity, but there still could be some structural defects on the inside of the weld. The integrity might not be what it should be. So that is what gas does. We control that with this flow meter / regulator here. We've got 2 dials on it, 2 gauges. So one with some big numbers. I'm gonna crack this one open, see what we got. And this one's reading quite low. So we are actually almost out of gas in this bottle. This bottle is showing about 250 pounds of gas, or foot-pounds of pressure in there. It's not a whole lot. These start out about 2,000, 2,200 sometimes. So this one is almost at the end of its life. But when we feed it out through here, which we do with this dial takes the bottle pressure and sets a working pressure. So right now my working pressure here is 37 CFH, which is actually too high. this should be around the 30, maybe 35 at the high point. Some people run between 30 and 40. For the smaller welding we're doing here, we can get away with less gas because we've got a nice controlled environment. We don't have breezes blowing through here like crazy. And it's just a good, calm, stable environment for welding. So I'm gonna reduce this a little bit just by turning this out. So we back it out a little bit, and as you weld, you'll see this needle drop down a little bit. Still at 37.5. I'm not gonna turn this on to get that lower, but we can do with a little bit less gas. Some people have gone as low as 25. 25 to 35 is kind of the range on good conditions. If you got a bit of a breeze, you might want that little extra gas there to help you out, just to make sure you got the coverage. Gas is fairly cheap. Having to go back and fix and repair welds is not. So that's maybe something to consider. Think about when you are using gas, but be aware too much gas can be a bad thing too. So let's take the Bow River. Let's think of our regular Bow River is our normal gas flow. Well, remember that great big flood in 2013? You guys were probably pretty young, but that flow is, or that flood pushed all that water through there. It had nowhere to go, so it went everywhere, right? We had whitewater rapids in some sections. We had flooding overland in some sections. Basically, what happens is when you get too much gas going on, you create those rapids. You force a high volume of gas through a little area. And it turns and it rotates, kind of like when water flows through rocks. It can pick up air, take air in, and that's why all the bubbles come out of the water. Kind of the same thing with this, except you got two gases mixing. Well, our atmosphere and our gas mixing. So that atmosphere comes out of here real fast and it's turning because it never flows out perfect because we always got little bits of spatter there. And spatter in the end of that gun, just like that, you can't see perfectly, but there's a glob right there on the bottom. That is going to create a rough spot in the gas flow and the turbulence. It's going to create that rolling bit in the air, and that could drag basically unwanted atmosphere into your weld. So too much gas is a bad thing. Too little gas is a bad thing. Got to find that sweet zone. We don't really want to go above 35, maybe 40 max. If you can get away with more, cool. But I think it just becomes a waste of gas after that point. So we talked about the bottle. We talked about the regulator. This just gets delivered to the welder via a hose here. This hose comes in the back of the welder on this side and goes through a tube. And there's also a gas solenoid in there. So when you pull the trigger, that gas solenoid activates, starts sending you gas. We're going to talk about the front of this machine here. So we have talked about the cables. Now down by the cables, we're just going to drop this a little bit here. So right down here by the cables is our main off-on switch. It's hard to see, it's kind of tucked underneath so it doesn't get bumped, but that's just a big toggle off-on. There's no lights or anything, but basically when it's on, you're gonna hear this thing hum. There's gonna be fans going. You might even hear it a little bit. What I often do is I'll walk by the booth, so I'll just put my hand over the back. There's some fans, and if you feel air coming out of the fans, you know it's on, so I always just double check them and shut it off. These shops get noisy sometimes. It's hard to tell whether it's off or on, but it's an easy way of doing it. This welder, some pretty simple settings. So this dial, hard for you guys to see, as maybe don't have the best view of it, but this one's got numbers all the way around it. 10, 20, 30, 40, 60, 60, 50, 60, 70, you know, on and on and on. This here is your inches a minute wire speed. And it's not talking about 10, 20, 30, 40 inches a minute wire speed. It's percent of a maximum. So 10%, 20%, 30%, 40%. And there's a bit of a guide to this, and I'll kind of go over that in a second. And this one here is your voltage range. So this one is set low voltage setting for setting 1, 2, 3, 4, 5, 6. Now we're getting into the spicy zone. 7, we are going to be, you know, cranking out some big welds, and that's going to end up duty cycling out this machine. So we don't want to, you know, run it flat out here, but we want to use a recipe from our recipe book. We have a weld recipe book, and it's going to tell us where to set this. That book is right here, front panel on it. So it gives us all of our consumable parts on a little piece here you can't see. It lists all the parts for the guns and the part numbers. Super cool and handy. Right here, this is a flip chart for steel, mild steel, aluminum. This helps us pick our settings for welding. So super nice because they give you the welder and they give you a base to start it with. So here is talking about steel. Okay, so we're gonna weld steel. So we might as well look at this one. Now it says wire type, solid or wire, and it's got solid wire here as well. So we're gonna look at this one, ER70S6, because this is designed to run solid wire, not flux core. The next category is gas. So the bottom one says, these are the settings if you're running 100% CO2 gas. CO2 is cheap, that's why we use it. Finish on it, not that nice. CO2 is cheap though. Less expensive than C25, but C25, it gives you that nice looking weld. So this one here is a C25 mix, a 75-25 argon CO2 mix. And then the next category down is wire size. So what size wire are we running? We're running an 035 wire. So we want to go down there to 035, then we want to follow these numbers. We got a bit of a graph here, and it shows steel thickness. That's a black blob you can see there. And then this tapers down, each thinner thickness. So here, looking at solid wire, C25 gas, 035 wire, and if I was welding 3/8 thick plate, it tells me here the settings are 5 and 55. So 5 is going to be on the voltage side, so we're at 3, 4, 5. We're getting up in that spicy zone, and 55 here, halfway between 50 and 60. That is going to be your ballpark setting for 3/8 plate. Now, with that, these are recommended settings. These aren't the be-all, end-all. You may find it's too hot for you, or it's not hot enough for you, or it's too wet, or it's not wet enough for you. And by wet, I just mean it's got voltage, that weld sits down nice. Everyone's going to have their own preferences, so you can feel free to make your adjustments from here. I would leave the voltage where it is, and I would play with the wire a little bit. Just fine-tune the wire to your liking. We also have different settings here for different thicknesses. I've got quarter, 3/16, 1/8, 14 gauge, 18 gauge, and 22 gauge, which is 0.08 millimeters, or 030, which is really thin sheet metal. So yeah, that's the basics of the operation on this guy here. Pretty simple overall. The big boy behind you guys can't see yet, is fairly similar as well, except it does more things. It's a power source with the wire feeder on it. So that is what we're going to take a look at in just a second here. I thought I saw a couple questions, so I'm just going to pop this chat open here and see if I can answer a couple questions for you. Yeah, all right. So GPU in the bad boy, welder on bags, you know, give it a little camber. Not this one. This is your Tercel. You ain't spending that money on Tercel. We're gonna spend that on like an S14. We're gonna do it right if we're gonna do it. We're not doing poor boy JDM here. So we're gonna do it right if we're gonna do it. And if I was gonna pick one to do it with, I think we are gonna go to this boy. This one right here. So this is not 2JZ, but it's definitely, you know, a good welder here. So what we have is this welder is our power source on the bottom. It's a completely separate machine from your wire feeder. This is just an addition we put on top of the cart. This takes its power from this guy right here. It's also got a remote plug-in for some inputs. This one is pretty tricked out. It's got dual guns. So I got one gun here, up on the top side. Hard to see, but I got 2 rolls of wire up there, 1 flux core, one solid wire. So we have a multi-purpose unit here. What I like about this is I'm doing flux core with my 20 levels right now. Flux core is this stuff here. It's like gas metal arc welding, slightly different. This wire has flux inside of it and it's hollow, whereas this one's a solid wire, steel all the way through. When we're doing the 1G, the open roots, we got to put our root in with solid wire. So I can flip over to that side of the machine, put my root in with solid wire, flip back over to this side of the machine, and weld the rest of it with flux core. It's pretty cool. It's definitely neat. The way this works is we got our power switch on the bottom. We're going to turn that on. And we should get some lights here in a second. There we go. This is providing power to this unit here. I haven't turned this top unit on. But down here, we have a control panel. And this is where we can select our processes. So right here, we're on the MIG setting, but we can move it over to lift TIG, lift arc TIG, scratch TIG, pulsed MIG, really cool. Constant current, we got our foot pedal TIG, we got stick, and we got voltage sensing wire feeder. So we're gonna go to MIG, because that's what we're doing. This number right here is our open circuit voltage. This one doesn't really matter right now because the numbers we're looking for are gonna be up here on this unit. So this unit is my wire feed unit. It draws its power from this guy here. Instead of plugging a stinger in here for stick welding, we actually plug a lug in that feeds into the back of this and provides power for this unit. So pretty cool there. This one has a side selector. I don't know if you can see this little toggle switch right here beneath my finger, but right now we're set up for flux core because the green light is illuminated on the left side. So I can hit that button and all of a sudden we're ready to go on this side. So we have our solid wire now ready to go. Top numbers here are voltage. 18.1 volts is where this is set at to weld. 183 inches a minute wire speed. We can change that by moving the wire speed up and down here on this knob. Or voltage, we can change that by moving this knob. Fairly simple. It's a neat process. It looks super complicated because we have a ton of cables on this thing. So if I swing this around, as you can see, we got cables all down the side there, gun wrapped up power cables. We got remote power supply cables on the front here, then our dual guns, and then we have more cables on the side. Also, we got our gas setup here. Gas is right there. You can see the bottles. We've got one bottle powering both sides of this. This is providing gas to both guns. Nice thing is, flux core and gas metal arc welding can use the same gases. So that's pretty neat. I never want anything to do with flux core in my life ever again. There's a pulse for MIG. I didn't know that. Yeah, pulse MIG, pretty awesome. Basically, flux core is awesome and fine. I just need to teach you more about it. I'm not saying you don't know anything about it, but I'm saying I can make it easier. I hate MIG. I'm definitely a stick guy, but I love flux core. Flux core is super easy. It is easier than gas metal arc welding. It's easier than stick welding. You get a higher quality weld. You just have to know how to run the equipment properly. So pretty neat. When we are welding with these guys, when we come back, we're gonna be using the solid wire side. So it'll be settings like, I don't know, 20 volts, 275 inches a minute. That is what we're gonna be using with that. And that is kind of my little spiel on this. So we can turn this off. We can actually change this over to stick. We take our ground clamp and then we pop a stinger in here instead of the power supply cable for this. And we can just do stick welding. It's really simple, super useful. I love these setups. Costs has come down on these quite a bit, but probably about, I don't know, $7,500, $8,000 for this. setup here. Not really something I want to have to buy a whole bunch of. These used to be up in the 20 range when the technology was fairly new. But since we are getting new technology, the cost is coming down. Yeah, we're definitely going sticko mode here. We'll do that when you guys come back. We'll see how you guys go. And I am a Scott, not Travis Scott, but you know, Mr. Scott, close enough. Mr. Scott's going sticko mode. There we go. Yeah, but no, it's super fun. When we weld this though, I want to talk to you guys about steel a little bit. Steel is what we're going to be welding, but we don't just grab the welder and weld it. We need to clean it up first. So what we do is when we're given our steel, it's going to look pretty raw. This one has been cleaned. As you can see, it's got grinder marks on it. Nice and shiny. This one, not so much. You can see the oil, the dirt, the grease, the grime. It's called mill scale. Oh, and there's oil and dirt and stuff on it too. But that comes from factory like that. And what happens is, you can weld your diff, but what I recommend is you pull your gears out, you put them in the oven, you warm them up for a good long time, you get them nice and hot, and then you weld them, you put them back in the oven and you cool it down nice and slow. That's gonna help normalize the steel, not be so shock treated from welding and not be shock treated from cooling it down. I'm not recommending you weld your diff because often the welds crack, but they hold together just because they're all intertwined and just together. But yeah, if you're gonna do it, that is the way I would do it if you're not gonna do it professionally. Yeah, it's kind of like the home thing, and I don't think your mom would really appreciate you throwing a diff in the oven. So, but long story short, guys, we have this mill scale. This needs to come off before we weld. That's why we have things like, whoop, right there, left side of the screen, we have a buffing wheel, and we got pedestal grinders. We just need to be careful with those. We're not getting our fingers in there. I recommend if you guys are using pedestal grinders, get some vice grips. You know, make it easy. Just like when you guys were putting the clamps or stamps on things, everyone's afraid of hitting their hands. You know, why put your hands at risk if you don't have to? So what we could easily do is clamp that in there, buff it all up, flip it, buff the other side, and we're good. So taking that mill scale off is very important. That comes from factory. When they roll all this out, they got these big rollers, they roll back and forth, and basically it creates this layer on top of the steel that isn't really steel. It is weldable, you can weld through it, but it's gonna give you guys some grief. Your weld isn't gonna turn out as nice as you'd like it to. And it's just really good practice to take all that off anyways. If you guys are doing some welding, yeah, taking it off is what I always try and do. It's gonna improve your quality of your weld. You're not gonna have any of this junk mixed into your weld, which is awesome.
Shut the fuck up, I'm not doing it.
Can we maybe mute ourselves if we are having difficulties? So what I have here is a tacked up piece. So I've kind of buffed this piece up a little bit. This one isn't so buffed up, but I tack it together in what's called a ladder setup or a stair setup. So I put tack on the end, tack on the other end, then I've got a space I can weld here, and a space I can weld here. And each piece we add on gives us another 2 welds. So that's just a really nice way to make the most of our material here and get lots of different welds on our plates. And yeah, you can stack this up as many as you want. Anything more than like 6 gets to be a pain in the butt. So I usually after about 6, I'll throw it in the bin. Give a person another couple pieces of these and they can carry on. But yeah, it's fun. I'm looking forward to doing this. And yeah, once again, we have some noise in the background. Hopefully it's, you know, not too crazy. But that's pretty much it for today, guys. So if you guys want to head out of here, you guys can. I
I
just
don't
want to say
understand. One
thank you
Piece is
for.
so savage. Why?
Barricade, you're unmuted.
Yo, I'm telling you right now, One Piece is wallahi is the best fucking anime.
Barricade, you're unmuted, man.
What story, okay?
Yeah.
Fool it.
So, yeah, that's.
I'm gonna watch this again, wallahi.
Yo, Barricade, you're unmuted. Mute yourself.
There, I put him
Oh
on.
my god.
Yeah, we don't need to hear any of that. So, put him on mute for his and our convenience. Yeah, so that's that. Anyways, thanks for joining me, guys. There is going to be a test. I'm going to pop that open in just a few minutes here. Drop your name in the chat. Remember that. That's my attendance. So please do that. Thanks for tuning in today. I'm going to leave this on. I'm going to shut the video and the mic down, but you guys will be able to get a hold of me. Just pop something in the chat, yell at me, whatever you want, and I'll answer any questions you guys may have, or if you need help with something from the other day, I can answer those questions as well. So thank you much, guys. I appreciate it, and I hope
Could
you have
we
a
say
great...
for the carboys that the separate from the wire feeder to the power source, that would be like compound turbos, and then like the all-in-one would be like a single turbo kind of thing for an analogy?
For an analogy?
Yeah.
So right there.
Yes.
Right there. That's our NA motor. This here
Naturally aspirated.
is going to be our, our turbo, our intake, and then we got dual turbos on that. So we got, if we're talking
twin
cars,
turbo.
yeah, we got twin turbo. Well, you can see them big spools up there. You can spool them up, right? So, and we got our piping. We don't have an intercooler, but yeah, we got to spool them up there. And we got some, we're going to push some happy gas through it too, right? So we got
Oh no, giggle gas.
Yeah, so we got twin turbos with NOS on
50 shot of giggle gas.
Yeah.
No, we don't need NOS. Just put brake clean in your washer fluid container, then run it to your intake, and then when you go to wash your window, it's just like a free nitrous.
Discount boost, my guy.
Yeah, there's a
Or
whole
like
bunch that
octane
can go wrong
boost.
with that.
Oh no.
I'm not gonna
I'm a big
support
fan
that
of it. I do
theory,
it every day.
But yeah, if you got an old diesel that won't start up, then
Yikes.
maybe think about that. But yeah.
They actually engineered something so for the old 7.3s.
Mhm.
Without the turbo, they engineered a mechanism that you press a button from inside the cabin, it sprays ether into your intake to start it, because they wouldn't start.
That's pretty redneck. Well, some of those old 7.3s, I don't even think they ran glow plugs.
No, they didn't.
Yeah. So
terrible engine. And then they thought, oh, let's put a turbo on it. It helped. Still a terrible engine.
Yeah. Yeah. Oh, they lasted, but yeah, they definitely weren't built like today's. Anyways, I'm gonna wrap this up, guys. So there we go. Here we got our NA motor on the bottom. We got our intake with our twin turbos with some NOS on top of it. So we'll call it a 250 shot. And you know, you can even run that at what, 35 pounds, right? 35 CFH. We'll call that pounds. So there you go. There's some car analogies for you. So we got 35.
That's some insane boost.
Yeah. And twin turbos. And yeah, so that's all that for today, guys. I'll let you guys take off. Hopefully Barricade doesn't get sorted out, everything he needs to get sorted out, and doesn't unmute himself. But that is what it is. All right, thanks, guys. I really appreciate it. I'm going to pop that test up in a couple minutes.